Good morning, guys. Hey, guys, good morning. I usually don't get the first slot, so I'll try to make the best use of it. First slot always exciting, right? I think Atul laid a excellent foundation to how today is going to go, and why platform engineering is important. And he actually gave one of the slides away. One of my slides talks about the need and the purpose of platform engineering as well, right? So let's get started. Before we start, I just want to get an understanding of the room. How many of you are all developers? Okay, and DevOps engineers? Okay, that's good. Then you're absolutely at the right place. Um, let's start. And just before I start with this, right, I want to do something here. Can you all hear me at the back as well? Okay, then I'll speak without the mic so that it's easier. So before we start, what I want to do is, I want to apply this, right? We'll come back to what I did there, but let's begin. All right. So quick introduction about me. I'm Bharath. I work for Mirantis. I work for the OSPO team, which is a open source program office team. So what we kind of do is we enable the company and the communities outside of our company as well to adopt, utilize, contribute back to the open source communities. So most of the work we do indirectly or directly goes back to the community, and we help develop those projects as well, right? Today, I'm going to talk about K0rdent. Before that, just a little bit about platform engineering. So when cloud started, it was an amazing promise, right? Everything was supposed to be simpler as compared to the on-prem environment that we did, and everything was supposed to be handled by someone else, like the major players like AWS, GCP, on-prem, OpenStack, and so on, right? But then, as in when the workloads started getting deployed and as in when the company started adapting it widely, we saw so many problems, so many challenges, and the interconnectivity between different ecosystems and different components in these ecosystems quickly grew, right? So it became just this complex web of API callings and whatnot, right? As we move on to, I can't even say future, like this says the future of intelligent operations, but the future is already here, right? Today, everything is moving around AI. So no matter what you do, no matter what kind of business you have and applications you're running, AI is getting integrated, or it's going to get integrated very soon. So there will be no normal applications, there'll be no efficiency increase or growth and future aspects without the integration of AI. So with this core theme in mind, we are heavily focused and pushing towards this future where we say that no matter what kind of cloud you have, no matter which operator or cloud provider you're using, this is going to be the center of operations, right? And as you can see, the center of operations is Kubernetes as well, because as we've seen for the past 10 years, industries that we never even thought will adapt Kubernetes has adapted. Telecom industries, which have like 20, 30 years legacy software, banking sectors which are crazy about security, military operations, and whatnot. Everything has been more efficiently run and better managed on Kubernetes. And that's why we want to focus there as well. So just a brief about the enterprise requirements when talking about platform engineering, right? As Atul already said, the developer self-service is one of the core themes of platform engineering. So, like I said, if you want to provision a cluster, if you want to deploy something on a cluster and run your application, we got to create a ticket, right? You follow up, you write emails, like what is life without tickets, right? It's always going to revolve around that. That is something platform engineering aims to change, where it should be as simple as like filling a form or something like that and say, hey, I need a cluster in AWS. I want it to run like 16 gigs of RAM. I want a 3-node cluster. and I want like 500 GB of SSD and so on, right? And it triggers a process in the backend, which is not a ticket, which is not going to go to somebody who has to manually do something, but rather an automated, scalable process which is catered to serve this requirement. Along with that, I want to talk about two important things here. The security and compliance and customization and visibility and control go hand in hand. So why it's important to support customization and visibility is because to cater to different set of requirements. So in an enterprise environment, you'll have different teams that want different things for themselves, right? So suppose a customer it could be a client or it could be your internal teams as well. If they ask for just a different set, or I want it to be deployed on Azure instead of AWS, then you can't change your entire architecture. You have to create the platform engineering base in such a way that you have that ease of customization as well as the scalability for the future, right? And security and compliance, like everything in the past 10, 20 years, right? Security has to shift left. So in one of the previous orgs I used to work for, we did this huge change in the entire organization where every person, like every team nominated one person to be the security champion and bring in these best practices, not towards the end of production or towards the delivery mechanism, but rather shift left towards the engineering and development side itself. That way, we think about security not as an end product or a second thought, but rather start with it from your core, right? And that's something that platform engineering has to and will concentrate. Moving on to the reality, I've like put up some numbers. I just want to pick up one number over here. So it says, this is one of the surveys that was done earlier this year. 76% of organizations have adopted some sort of multi-cloud strategies. And when I say that, it says 2 or more clouds. So you either have like AWS Azure, GCP and AWS, OpenStack or AWS, 2 or more clouds, right? But shockingly, just 29% of them have any root, platform engineering values and processes set up around it. So what happens is people will think, okay, now because AWS is very famous and it provides everything that I need, let's do that. And then they quickly run into the problem of, oh, this is not going to work for me. Let me try GCP. You keep doing this, then the management becomes extremely difficult. And that's what this proves, right? And to mention just about the point of multi-cloud, right? Nobody wants to get vendor lock-in. Like I think I have another slide which talks about this, but this is becoming more and more the norm. Yeah, this one. So now when multi-cloud is the problem, what possible solutions can we bring into this, right? One is do nothing, of course. So many organizations go down this rabbit hole, and then after 5 years, everything is so complex that you touch one piece of code and everything just breaks. We've all been there, right? So just like the example I've shared about development in a project, the same is applicable even for DevOps and platform engineering and the management at an overall level. Then you have the DIY open source. So this is brilliant, and this is what we champion as well. Everything is out there. Kubernetes especially has created this wonderful ecosystem where you talk about any aspect of your IT, open source solutions for that exist. You talk about security, there are things. You talk about provisioning, there are things. You talk about scaling, there are things. You talk about observability. Observability is endless. Like there are more companies in observability than, so many other sectors combined together, right? So you have it all. But the problem with that is, because there are so many solutions and because your company needs a particular way for things to work, picking and choosing and maintaining it all from end to end becomes a real challenge, right? So you introduce one tool, that's not the end of it. You have to introduce another. Then how do you make this talk to the other tool, and so on. Proprietary solution, this is the thing I mentioned. So you go with one company, everything is great, but then slowly and steadily but surely there will be a vendor lock-in thing that will happen. And we've all seen like the infamous Broadcom example and how people are really, really running away from VMware. Again, that's just an example I'm talking about, but there have been so many other examples as well where the vendor lock-in has really affected companies. And that's why I want to talk about this enterprise grade open source solution. So many companies have literally modeled their entire business plans and structure around this model. So one of the famous ones you would have all heard is Red Hat, right? So every product that happens in Red Hat will be upstream open source as well. But you might be wondering, like, how the hell is the company making money, right? So large parts of VMware, AWS, Apple, not Apple, but Apple has certainly started contributing back to the community, is dedicating its engineering resources, its hardware resources, and so much more towards the enterprise solution, wherein it gives back to the community as well as adapts those systems as well, right? One such solution is K0rdent for the multi-cluster, multi-cloud problem, right? So everything that we do, like I've mentioned, gives back and adapts from the open source community. Largely, there are three components. You have the cluster management, you have the state management, and then you have the observability. So let me start with the third one, observability. So no matter what solution you develop, if you don't have eyes into what your tools are doing and how much you're consuming, what's happening with logs and metrics and all of those, right? It becomes really challenging to monitor. And that's why we've baked in observability. And again, this is not a custom solution. This uses Prometheus, Grafana, OpenTelemetry, and a bunch of other projects from the upstream. Then there's the main other two. So there's cluster management and state management. So cluster management is the component that's responsible for the actual provisioning of clusters across your clouds, and state management is for the day two operations. So you have these clusters, right? Great. But what happens from day two? What about the deploying of resources? What about the provisioning of services across your clusters in a scalable, unified fashion? All those things are taken care of by state management, and that uses another open source project called as Sveltos. Right? So just want to briefly share this. This is the stack that K0rdent sort of works on, where the bottommost layer is your infrastructure. It could be on-prem infrastructure, it could be edge, it could be your public clouds, it could be, in Europe there are a lot of sovereign IT providers where they are extremely strict about the regulations there because of the country's regulations and because of how things work there. So it could be your really niche providers, right? And you can build on top of that. But the topmost layer is your application stack, right? These are all the things that you as your company and developers would do. And right here in the middle is what I'm talking about K0rdent does, right? So there's Mirantis Kubernetes distribution, which is K0s. So all of you might have heard of Kind, right? And K3s, K3d. So all these are Kubernetes distros. K0s is one such distro. So K0s is an extremely lightweight Kubernetes distro, which runs as a native Linux process on your laptop. So that's why, as compared to the other ones that are out there, this is very light and it's capable of running even on edge. And that's what K0rdent uses underneath as well. And then there's the cluster management, state management, and the other orchestrators in the middle layer, right? So just a little bit deeper into the cluster management tool. So I said cluster management is for provisioning clusters, yeah? And I said we use open source projects. Which open source projects do we use? It's CAPI. So CAPI stands for Cluster API. CAPI is directly under the Kubernetes org. So just a very brief history. When infrastructure providers like AWS, GCP, everybody started providing solutions, everybody had their own way of provisioning Kubernetes clusters. So the Kubernetes folks realized that this could be a big problem, and what they did, they standardized the way you provision clusters, right? So they said there is one way to provide, there is this one standard way that everybody can adopt and use to provision clusters, and everybody accepted that, and that's the upstream solution. So we use CAPI, under the hood for K0rdent as well. And the state management, there's the Sveltos controller. And then this is how the cluster definition looks like. I've not put up detailed slides about this because I want to show you live using the terminal. So briefly, there are these three things that make up your cluster, right? There's the cluster deployment. The cluster deployment defines three things: the cluster template and the service template, right? So the cluster templates defines the configuration of your clusters, and the service templates defines the configuration of your services. So when we see that example, I think it will become a little more clear, right? Now jumping into the bulk of the talk. So all this is great. Platform engineering and the solution that K0rdent provides is good. But what about MLOps, right? So we have to realize one thing about AI building and applications. AI isn't just about the models. If you don't have a strong infrastructure that's serving these models and serving them well, then two things will happen. One is your user satisfaction will go down because you're not serving them efficiently. Number two, your costs will go skyrocket. So I don't know how many of you have used GPUs, but if you go to any public clouds, the GPUs are very expensive. Just run some workloads on it, leave it for like 15, 20 minutes or 30 minutes, and then go to your billing section and see the costs will be really high, right? So that's why it's important to provide a good infrastructure for the underlying thing. And like I've already said, Kubernetes has really taken the market by storm, and it's ideal for AI deployment as well, because it does a bunch of things which we'll have to manually do when we deploy AI on traditional servers, which is inherently taken care by Kubernetes, right? So it provides a very good base for us to use Kubernetes for deploying AI apps. So I think this is the last slide before I move on to the demo. There's the cluster deployment. It defines the cluster template and the service template. And for the AI application that we'll use, we'll be using all these services, right? So all these are upstream services. All these are applications you might have already heard. NVIDIA GPU operator to install the required drivers in order to help Kubernetes understand the underlying service, that this is a GPU-enabled cluster. Cert manager for certs, Istio for services and routing, Knative and Kserve for the actual inferencing, right? So this is the power that K0rdent combined with Kubernetes gives you, that this whole thing, this entire thing is just defined in one single YAML file. And this is extendable. If you want, you can remove services, you can add services, you can upgrade them, you can downgrade them, you can have multiple versions of them running simultaneously. One team might use one version, another might use another version. You can do A/B testing, and all these things are simplified in this format. All right. So let's go to the demo. Let me turn this way. Okay. So we applied something earlier, right, before I started. So this is sort of the 10-minute delivery challenge. So that's the hype all across India. We want everything in 10 minutes. So here is our attempt at 10-minute cluster delivery as well, right? So I already applied the cluster deployment. Let's see. So this is the one that we applied. The services take time to come up, but then the cluster itself will be ready, right? Okay. Now let's go here. This is the, yeah. Okay. More, yeah. So this is the cluster that's deployed. Okay, let's just take a look quickly. Yeah. So this is your cluster deployment YAML file. It primarily has, like I said, two things. One is defining the spec for the cluster, and down here it will be defining the spec for services. And all you need to do is just mention the list of services, and then you can override any values that are required, just like how you do for your Helm charts. By the way, everything underneath are just pure Helm charts. So if you have any service, if it has a Helm chart, it'll work with K0rdent. And if you're developing your own application, ultimately you'd need to package your application into a delivery mechanism, right? And Helm is one of the most widely accepted, adopted mechanisms. So you can package that and you can reference your Helm chart, right? So whatever services I showed you, those are like GPU operator, Istio, Cert Manager, Knative, and finally Kserve, right? Up here is your actual cluster definition. So I've used Azure for this, and you can use pretty much any cloud. And as you can see, this is like specific Azure related configuration. So I've defined like the control plane stuff, I've defined the worker stuff. So one thing to notice here, which I want to highlight, is this part where the worker nodes, you can just mention the flavor or the VM type you want to use. And this one is using Tesla T4 GPUs, right? This is how flexible and scalable it is. So up here, I also mention the number of worker nodes and control plane nodes that I want. And you can modify this by patching the YAML, and you can scale up your cluster as well. So that's all there is, right? So you have cluster deployments, and you can have multiple cluster deployments. So in this, I've defined like a bunch of them for different purposes. If you don't want a GPU one, like you can just deploy a normal one. A GPU one, you just have to change the flavor and then include the appropriate services as well. Now going to the demo, let's see. I hope I haven't messed it up because I had a backup cluster, but you know how demos go. So I think maybe when I applied the earlier one, it overrode it. Let me see. By the way, this is how you get the kube config for the cluster. So it will be stored as a secret, and you can just export it and save it as a kube config file. So if you're building a platform around it, right, then it's just a matter of just fetching the secret and giving it to your user. Let's do that, and then let me do uh-oh, I think something's wrong. Yeah, I think I messed it up when I applied it initially. But ideally, what I want to show is the cluster that's provisioned, right? And then this would have the inference services which I had deployed earlier. Guess we'll have to see it this way. Yeah, I think I wanted to apply a new cluster deployment, but at the start of it, there was already an existing cluster, and I applied it again, so that overrode it, and probably something got messed up there. But let me show you this part, right? I think we're almost out of time, so let me wrap it in like 5 minutes. This was the AI application that I deployed. Inference service is a Kserve custom resource. So this is how it looks like. This is a Kserve custom resource. You define your inference service. And what I've defined down here is my application. The AI application is basically real-time speech translation, right? So you give an audio file in one language, and then you specify the target language. It gives the output in another target language. And it's using AI models underneath. So in order to demonstrate this, what I had done was I had split it up into 3 parts. The first part being it takes the audio file, converts it into text. The second part being it takes the text file, converts it into the text of the target language. The third being it takes the text from the target language and converts it back to the audio. So it's a 3-stage process. The reason I had done that is to show the flexibility of inference services and how scaling up and down happens, right? So here I've mentioned the minimum scaling and maximum scaling using an annotation, and that's all you need to do. Typically in enterprise environments, you can actually put this down to 0. So what happens is your GPU is not costing you money when there is no real request coming in from people. So it's just sleeping. And then when the request hits for the first time, K0rd notices that, it passes that request, spins up a pod, and then gives you the, it basically runs the workload, right? And those are the 3 inference services that are deployed here. If I have to show you the pods, right, this is the final connecting pod. So I mentioned 3 services. Then there is a pipeline application that is taking this entire workflow from A to B and then patching it up and then serving it. That is deployed as a normal deployment in a pod. It's available here. So when users hit this endpoint, this particular one, I've just queried for the health endpoint, but if that worked, I wanted to show you a real-time translation which should have actually happened by sending in a real request. But I guess, yeah, demo gods didn't play nice with this, even though I prayed for them. So that's about that. I want to wrap it up. Just before I wrap it up, I'm going to show you the upstream resources that will be helpful. So this is the project that I'm talking about. I guess there is some problem with, I think it might be a problem with the Wi-Fi also, with the cluster, I'm not sure. It might be blocking the request because I'm querying the cloud and that might be sitting behind a firewall. That's also a possibility. But let's see. So yeah, I don't know why it's even blocking GitHub, but okay. GitHub is completely blocked? Okay. At least this opening. So K0rdent.io is the thing. I think you guys can access like docs and GitHub from here. This is an open source project, completely welcoming contributions and trials. And for individual developers out there, I want you guys to take a look at this K0s. This is the underlying Kubernetes distro I talked about, which K0rdent uses as well. And recently, K0s was accepted into the CNCF community as well. So we are almost in the process of transferring this entire thing, to upstream CNCF, repo. So yeah, thank you so much. If you have questions, I don't know if you have time, maybe we can skip and then.
We can take a couple of questions if we have any. No questions?
Yeah, and this is my GitHub thing. Sorry, LinkedIn. So if you guys want to connect, I'll be more than happy to connect, and then we can definitely catch up.